that's not exactly what this pathway is, but just to remember how GPCR is attached with epinephrine and glucagon. They're opposite. Well, yeah, close enough. Okay. So remember, there's 3 different subunits. You know? Okay, see you later. There's 3 different subunits. What are they?
Alpha Q, alpha I.
Okay, so Q,
Like
I, and S. Remember, this is our KISS that she mentioned today. Here, I'll draw it better. Q, I, S, S, and S.
That's better.
Not really. Why are there 3 S's? What?
You'll see.
It's beta 1, 2,
Okay.
and 3.
So, in order to remember...
Is that just how you write your Q's, or is that like a special?
That's how I write my Q's.
Oh, okay. I wasn't sure if that was like a special.
That's like a normal
notation.
Q. That's a fine Q.
Whatever.
Okay.
Sorry.
So, the way to remember what is an alpha 1 or an alpha 2 or a beta adrenergic receptor is this. So, alpha 1, alpha 2, and these are all beta. So if there's a question about a beta receptor on the test, you know it's going to have something to do with the G alpha S subunit. Okay? Got it? KISS, and then A1, A2, B.
So.
These are our receptors.
Okay.
These are our, what's the word? Yeah, type of GPCR, our reaction, I guess.
Okay.
Okay.
I
You'll figure it out.
Yeah, I need to look over it.
Okay, so S and I are paired. Okay? S means start, I means inhibit. Okay, this is how you can pair the 2 together. They're almost identical, or they're very similar. Okay, I'll show you what I mean, because you look very confused, Gina.
Oh, yeah.
Okay.
Tell me another story. I seem to get this.
So here's our membrane, and here's our integral protein, aka our receptor. So we have our ligand come by, let's call it epinephrine or glucagon, doesn't matter. Okay? So it binds to the receptor. The receptor is bound to a couple things. So we have our G alpha subunit, S subunit, or you could look at it as gas. Gas means go, right?
Okay.
Okay? This is bound to a GDP molecule, and it also bound to a beta and a gamma subunit. Okay? And this is prior to binding, I guess I should be more specific. But what happens is our ligand comes by, binds to the receptor, and causes a conformational change. So what will happen is this GDP molecule gets kicked off. Okay, I like to think of this as a car. Okay, so our GDP is our nitrous oxide. That makes us go really fast, right? So we have our gas already, but we want to go really fast. But this is empty. GDP is empty, right? So we kick it off, and we replace it with a new fancy nitrous oxide, aka GTP.
So the GTP. Oh, okay. It takes place.
The GDP gets kicked off. It does not get phosphorylated.
Okay.
We do not fill up our tank, our nitrous oxide. We replace
just get
it
a whole new
because
car.
we have so much money that we don't give a shit. Okay. The process of binding this GTP.
Sorry. Okay. GTP.
The process of binding the GTP decouples the beta and the gamma subunits. Okay. So we have our car, we put in a new nitrous oxide tank, and we throw off all the crap that we don't want, right? These are heavy. So now we want to go as fast as possible, so we want to be light.
Okay.
So out here, we have our beta, oh, that's a triangle.
That's delta.
We have our beta and our gamma subunits. So we put on our new nitrous oxide, so we can go really fast, but we want to throw off all of our crap that's irrelevant, our baggage, right? So now we're lighter, so we can go. We can go really fast. So this goes and binds with a molecule called, or interacts with a molecule called adenylate
An enzyme.
cyclase. It is an enzyme, yes. Okay. What?
It's an enzyme.
It isn't. I think so.
I'm trying to think of the picture.
I think so. I think it's in the membrane.
It looks like it's in the membrane. Yeah.
Yes.
I just have a question. So I know the little where the receptor is.